All right. So we're gonna take a little quick review of kinematics, right? Online, you're here, right? You're waking. Everybody online waking, right? So I'm gonna focus on the differentiation and integration part of kinematics, right? So you remember kinematics has three main things, right? Or three main quantities that we need to understand, right? The first quantity that we need to understand is displacement. Remember, it's a vector quantity, right? There's a vector quantity and there's a straight line distance from start to finish. Let's call it S. Velocity V. Acceleration E. Right? So how do we go from one to the next? Right? If you remember, velocity is displacement in time. Acceleration is change in velocity in time. Okay? So in order for you to go from displacement to velocity, what you do is you differentiate displacement with respect to time. So if I give you an equation looking like this, S is equal to 5t squared minus 3t. And I said to find the velocity, all you have to do is differentiate the velocity, differentiate the displacement with respect to time, and you'll get 10t minus 3. Okay, so we went from an equation of displacement to velocity, right? And of course, velocity to acceleration, you differentiate velocity with respect to time. So if I tell you to find acceleration, you differentiate in your velocity with respect to time. That's okay? And if you differentiate to go down, go up, what you'll do? Integrate. So to go from here to here, to find velocity, you integrate acceleration with respect to time. To go from here to here, to get displacement, to integrate velocity with respect to time. All right, copy it down. Let's try some kinematics questions, right? This all you really have to know, but you also have to remember what displacement is and what velocity is. Alright, so there you go. Right, so sorry about that. I'll just turn it up. Right upside down. So let's go, right? So you will have to identify in the question if you are going to differentiate or if you're going to integrate. Right? It's a lot easier now in the actual exam because you'll only use the integration side of it. Or the question separated. You see differentiation, so you know you have to use differentiation in part C. Okay? It will be under the integration question, so you know do the integration. Right? It's not like before when they give you a kinematic question and you have to figure it out. But I am giving it like that. You have to figure it out. Right? Now, right, following, remember to fill out the cash flows form, right? With the advertised next week. Yes? What? No, I post on the TikTok. I'll look at a new one. That's why I'll look at somebody to come and do a TikTok with me. Okay, I'll let you. I'll make some up. All right. Yeah. Yeah, you come and do it. All right. Let's try this one here. Right. I'm gonna call it out, right? So, right, as we go, we're talking about it, right? A body moves in a straight line. A body moves in a straight line. And its distance s from a fixed point is given by, and its distance s from a fixed point is given by x is equal to t cubed minus 6t squared plus 9t plus 56. I wrote it down here. T cubed minus 6t squared plus 9t plus 56. Where t is the time in seconds. Although when I'm at the before, I give my idea when you're multiplying times starting, right? Right? If I want to do a revision class and an all-day class, and I don't know if I will do it all night. I'll take long to cover from that. So I do a whole day, 8 to 8 or 8 to 12 or something. Next week. Following week, right? So I have next week, Saturday, Sunday, and I'm going to go back up Tuesday at 11. Next week. Yeah. Okay. Yes, I might do that Saturday. Whole day meeting again with the most. I know it's right now we'll get this up. We'll break it down. And then anyway. Right, yeah. So where t is the time in seconds after motion has begun. Where t is the time in seconds after motion has begun. Find part 1. Part one, online, you'll get it, right? So T is just time in seconds. Part A of part one. Part one, find its velocity after 4 seconds. Find its velocity after 4 seconds. Find its velocity after 4 seconds. Part two, find its acceleration after 4 seconds. Find the acceleration after 4 seconds. Part three, find the time taken. Find the time taken when it is momentarily at rest. Momentarily at rest, underline rest. And the part four, the total distance moved in the first 3 seconds. The total distance moved in the first 3 seconds. The total distance moved in the first 3 seconds. Right, so take a look at the first one. Any ideas? How are you going to get velocity? Or what equation I gave you? What equation I gave you here? I gave you displacement. So how are we going to find velocity? Differentiate. And then I asked for acceleration, right? So if you have velocity, how are you getting acceleration? Differentiate again. That's okay? What does momentarily at rest mean? Velocity is 0, right? Momentarily at rest means that your velocity is 0. Okay? And then with the last part should be easiest, right? So give it a try. Try all these parts there, come on. Try all the parts. Online, message some answers, right? Because I feel someone is sleeping still. Narayan, there? Emmerich, Solid there? Samir. Sebastian now joined, so you should be waking, right? Yes, ma'am. Okay. Right, you can message them or yeah, we have to. Right, 200 come and do it on the board. I want to record a little. Huh? What? Oh yeah. I got some pretty thick sense. So. Oh yeah. Got that? Right, be careful with the fourth one, right? When you go ahead and differentiate, plug in a value, right? So you may just plug in four, yeah, plug in four in each one, right? Yeah, take your time with the fourth one. I can't do that now. I just waiting on online to send some answers. Yeah, I'm trying to work it out just now. Oh, yeah, please, sir. Are you done? Right, part D, be careful with part D. Part 4, be a little careful. Right, always have to look out for those little things. Right, but if you think it's straightforward, go right ahead. But let's have a little small twist. All right, let's go. Let's see where you come up with, right? As I said, part 1, 2, and 3 should be right. Part 1 is to get velocity, which is simply differentiating this by following this info here, right? So that'll be 3t squared minus 12t plus 9. Everybody comfortable with the differentiation, right? So now they want to know when t is how much? T is 4. So you'll get v is equal to 3 by 4 squared 12 by 4 plus 9, which is 9 meters per second, right? That's why they gave you the info on time in seconds and so on. Next is acceleration. So you differentiate again. So that'll be 6t minus 12. Then you plug in t is 4. So a is equal to A is equal to 6 by 4 minus 12, which is 12 squared, right? Please remember, learn to put in the SI units, right? That'll be meters. And then this said momentarily at rest, which means that the velocity is 0. So I am going to put 0 in which one? Equation 1, 2, or 3. Which one? And this one, right? You're going to put V is 0 here. So that will be 3t squared minus 12t plus 9 is 0. And when you solve it, you'll get t as 3 or 1. Right? You also saw the video I did on exponents, right?
Yes.
Go back over those things, right?
Yes, sir.
Huh? Which one? All of the audio part? So which one? Let me know which one's the audio. Yeah. I'll stop that. Yeah, separated and I lower it, but I still think it was still too high. Yeah. Yeah, that's what I learned. Right. So here's the problem, right? The problem is the problem is the displacement. I mean the distance traveled. What do you ask for? The distance traveled in the first 3 seconds, right? So most people for part 4, they would just put t is equal to 3 and they got s as what? 56, right? But that is not a distance traveled, right? Let's take a little look at what's happening to the particle, right? So do me a favor. When t is equal to 0, plug in t is 0 in here. What you getting? S is what? 0, 0, 0. So you will get 56, right? Right. But you have to see what's happening, right? T is 1. Plug in t is 1 to minute time away again. So you'll get 1, 9, 10 minus 6, that's 50. You will get 6. That's okay? And then do t is equal to 2 for me. Do t is equal to 2. How much? 58. And then we did t is equal to 3. And we got 56. So the question asks for the total distance traveled in the first 3 seconds. Right? So I want you to pay attention to what's happening, right? So at the 0 second, he's 56 meters from where he started, right? This is just let me put start so I don't mix it up, right? So this is when t is 0, one line you'll see in there, right? That's 56, right? And then in 1 second, he reaches 60. All this is meters. But then when he's at 2 seconds, he's at 58 meters. So 58 meters means he go back somewhere here, right? Right? So he went back like this. Okay? He went back to 58 when t is equal to 2. And then when t is equal to 3, he went back to the 56 meter mark. You're seeing that? So what is his total distance traveled? He started here. Here to here is how much meters? 56 and 60. So that's 4 meters, right? That's okay? And then at 60, he went back to 58, then back to 56. So he started at the 56 meter to 60, that's 4. Right? And then he went back to 56 again, that's 4. So therefore, his total distance traveled will be 4 plus 4, which is 8 meters. Just start here. No, he didn't start there. When T is 0, he was here. Oh, probably get a head start. All right, so let me just go into it for those who find it not making sense, right? Right. Everybody, keywords. Huh? Right? What's up, there? Right. Let's see if we can paint the picture over, right? This equation gives us the distance traveled at a particular time. Distance traveled, right? So therefore, it kind of gives you an idea where the person is at. So the race probably started here, right? But this person was fortunate, he got a little head start. So when T is 0, that's where he really started from. He started at the 56-meter mark. Okay? Everybody okay with that? That's when T is 0. He got a head start. Right? Then when T is equal to 1, he was at the 60-meter mark. You okay with that? From here to here, he traveled 4 meters. That's okay? When T is 2 now, he was at the 58-meter mark. So that means he came back here. So he going back the next way. You okay with that? Yeah. Because what this equation given here is how he behaves as time changes. Right? So it's not 58 more. All right? That part's a little tricky for you to see it. But yeah, so yeah, technically you calculate. You're not giving any total. Right? You're giving you when T is 1, where he's at. When T is 2, where he's at. When T is 3, where he's at. Okay? And this is when T is 2, and then T is 3, he right back here. So therefore, he went this way 4 meters, then he went this way 4 meters. That's okay? So his total distance traveled is what? Right. So now, what is his total displacement? I don't know what the man doing. Yeah, well, I don't know why the man went back to start.
So they probably done a blanket for food.
Maybe it's a circular race or something.
Same.
Right? That's good. Right. Collier, what's the total displacement? Zero. Right? Because he starts and he finishes at the same point. So his total displacement is 0 meter. That's okay? So you have to look out for these little things, right? All right, copy it out. That's why in questions they only give you like 2 seconds or 3 seconds because they want to mark it out. Right? Let me check out online here. Pardon me, ma'am. Yeah, Joyce, you have an idea what's going on? Yeah. They want you to later. Yeah. But a whole question would be like a whole question would be like 10, 25 months. That the whole exam. Copy it down, right? Ready? Let's go again. That's good. That's something like this. All right, that's the best I can do. Somebody show out the zoom there. Control and maybe that's zoom in there. Huh? Right now, it's yeah, what's that? Very wrong way. Huh? Lots. Oh. Good boy. Y'all seeing that? I do not to school up. I don't know why it's moving down there. Alright, that's the best I can do there. Take a 24 and needed. Huh? Oh yeah, try it quick. It's on top before from my place. Right shape particle, for those who can't see, a particle moves in a straight line and passes a point O with its velocity. So the equation it gave you is what? Velocity t, right? Where t is the time after passing O. Find the distance of the particle when t is 3 given that the particle starts from O. So if they give you velocity and you want to get distance, what you doing? Integrated. Very good. Go ahead. Try it. I'll tell you that song. Try it. Try it. See what you think makes sense. Yeah, come to picture. All one video, any particular topic or I'll do some love, right? I don't, oh yeah, it's all in names, so I don't know how to tell what I had to go in the ask something about the name or yeah, something. Okay. Pardon me, ma'am. You're done. Take your time. As I said, they give you velocity. They give you velocity. So what you're going to do? Integrate. right? And they want the distance when t is 3. So what you gonna do? Substitute t as 3. You don't have to do this long thing here. Right? All they said is when t is 3. Okay? But you have a slight problem. Plus c. When you integrate, you're gonna get a plus c, right? But there's information there to help you get rid of plus c. Integrate here. Hurry up now. Right? So you will need help to find c, right? What does the last 5 words say? 1, 2, 3, 4, 5, 6, 10 words. Right, the particle starts at O. So what will be a distance at O? And what time you'll be there? Right, so you know that distance is 0 when time is 0. That will help you find C. Okay? That's okay? Bradley? So after you integrate, right, and you get your plus C, tell them when T is 0, S is 0, and solve this. Right, the information always in question, how to find the C. Alright, online? So find for C, when you solve for C, plug in T is 3 and let's see what you get. The question said that given that the particle starts at O. So if it starts at O, T is 0 and S is 0. Right? It didn't behave like this particle is started at 0. S is 0, T is 0. Right? So after you integrate, plug in S is 0, T is 0, and then solve for C. Right, solve for C. And most likely you get C as well. C is 0. Right? C is 0. Not doing that because this one they asked what happened in the first 2 seconds, so they mark it down. Right? Plus, they told us in this one it starts at 2. Right? T is 0, they start at 0. Right. So this case, if it starts at 0, right? And your total distance or your total distance displacement was and C. Right. So all the problem access is between if we had changed direction, let's see what happens then. Everyone. In this case, yes, that's all they want to do. That's all they want to do. Yes, that's all they want to do. Right? If this like full water, three, that's different. Right, 1 minute again. Online message, Eden, Crystalline. Crystalline, you message last week, yeah? You can message this week too. Or you take another rest. Right. So what is here? So question asks us to find displacement. So displacement is the integral of velocity with respect to time. That's okay? So we are going to integrate 2 minus 2t. Right? When you integrate this, you'll get 2t. Add 1 to the power, divide by the power, plus 4t cubed and 3 plus c. So this is s is equal to 2t minus t squared plus 4 and 3t cubed plus c. Right? Problem with this is that we have a t. So we had to go back to the question now and see what they said. They said that it started at 4, right? Which means that when t is 0, s would have been 0. Okay? The last example that we didn't start at 4. We started it later on. Okay? So now you plug in s is 0. You'll get 0 here plus c. So c is 0. You're plugging in 0 everywhere. So you'll get c is 0. Okay? So now the equation is s is equal to 2t minus t squared plus 4 and 3 t cubed plus c. Sorry. C is 0. Now, what they want? They want the displacement when t is equal to 3. That's all they want. They want the displacement when t is 3. Okay? So this equation will give you that. Right, so I'm plugging in t is 3 here. Sorry, 3 cubed. So now we have the distance traveled. Sorry, not displacement. This distance traveled. What's that? 33 meters. Right? The question only interested in what happened here. If the question said what happened in the first 3 seconds, then we would have to check what happened at 1, what happened at 2, what happened at 3, and then map it out. All right, copy it down. Let's go again. Well done. I take point up the next one. Oh, yeah. Right, this one a little bit better. Why down there? All right, go ahead. That's take your time. Right, look at what I give here. Look at what you want to find. the time. Right? It's always easier to differentiate it when you expand it out, right? Remember that, right? Yes. Is there quotient rule or product rule for integration? All right. So if you have to differentiate or integrate, expand without rules. Right, so you have to figure out if the differentiate or integrate. So the question needs to be known. Now we do it. And you write that down here. Right, I want to give you, what you need about. You're done? I can look at that now. So, what we're doing for the first one, Leonardo, right? Or Leonardo? Leonardo. Party, what are you doing? Differentiation or integration? Yeah, differentiate, yeah. Nice. Petit, what are you doing in part B? Integrate or differentiate? You want to get distance. Right? Because you have velocity. Oh yeah. Right, be careful in B. You're going to get the same problem where you have to figure out how to get C. Okay? I'm going to ask Bradley how to help me with C. Start, right? Give me a little minute again. Give me a little minute, 2 minutes. Right, I was going to ask Bradley something. Bradley, how again? So part A is just differentiate, right? And plug in what? T is what? T is the 3, right? Part A, I mean, part A. But part B now, to get distance, we said you have to integrate. Right. But before you try to see what happened in 2 seconds after, how we can see? Last time we had T is 0, S is 0. Right? What information they gave us here? Think about it. They have to give us an S value and a T value. So just read back, be there. Yes. Right? Did they told us when T is 1, S will be distance from P is 2 is sure. So the question said find the distance from P 2 seconds after passing P. Given that the distance from P is 8 when T is 1. So they gave you when S is 8, T is 1. Okay? Right? So they gave you V is equal to T by 4 minus T squared. Right? So do your thing expand it out first. And I'm gonna remove it. That's not right. You're done. I get cover it. Oh, you now gonna start part B. Oh yeah. Right quick. Okay, one thing get distance and you have velocity. So what you have to do? Integrate the velocity, yeah. Right? And then find the C. Let's see if we can do a few more, right? Pay attention to the unit, yeah? It's in centimeters and not meters. Right? So the acceleration will be centimeters per second squared. Let it do it. Oh, yeah. Right? Then let's give it a try. Let's give it a try. So acceleration is the differentiation of velocity. So that'll be 4 minus 3t squared. So to get the acceleration when t is 3, it's 3 by 3 squared. So that's what? Minus something. So negative 23, right? Centimeters per second squared. It wasn't centimeters, right? You okay with that? Yeah, everybody okay with that? Now, they want us to get the distance from P 2 seconds after passing, right? So to get S, we know we have to integrate V with respect to time, right? So we're going to integrate 4t minus t cubed with respect to t. So when we integrate 4t, we'll get 4t squared on 2 minus t cubed on 3 plus c. Did you put that? That's an only out. Yeah, make a mistake. So S is equal to 2t squared minus 1/4 t to the 4th plus c. That's okay. Problem is we have plus c. Right? But the question told us when S is equal to 8, t is 1. So I'm plugging in S is 8 and I'm plugging in t is 1. And I'm going to solve for c, right? So this will be 8 is equal to 2 minus 1/4 plus c. So c is equal to 8 minus what? 1 3/4. How much is that? What is that? 6.25. So that is 6.25, right? I'll leave it like that. Yeah. No, I'm moving across this to solve for C. Right? Always remember, watch the TikTok video, right? Always remember that the C had to be on this side, right? Such something like the formula you can watch back that. Right? So S is equal to 2t squared. 2t squared minus 1/4 t to the 4th plus 6.25. Right. So we want to see what happening when t is 2, right? But what will happen in here? Right? And I want you to pay attention to this, right? I want you to pay attention to what does this negative a mean? Slowing down, right? So let's just make sure we know what happened to the particle all the different times. Okay? That's okay? Yeah, we gotta pay attention. So let's see. So we'll be good and check and see when t is 0. Yeah, we gotta know the particle slowing down. This question really to work on. Oh shucks, I got to go. What is that? We last part B. Right. Right. So they want to know 2 seconds after it passes B distance, right? Did they say it started at O? At P? They didn't say that. So we had to see what happened, right? We had to see what happened there. So when S is 0, sorry, when T is 0, S is equal to 6.25. Right? And as I told you all, it's not going to be values bigger than 3. So if you're not sure when to use this method or not, use it all the time. Plug in T is 0, T is 1, T is 2. And see what happens. That's okay? Right? Do me a favor. So when T is 0, it behaves like that. Right? When T is 1, we got S is 8, so everything looking okay so far. And when T is 2, we all got S is what? 10.25. What the question asks for? The question asks for the distance from P after 2 seconds, right? So the question asks for distance from P after 2 seconds. So where is the particle in P? And here. And this is P at 6.25. So from T is 0 to T is 2, what's the distance? Take away 10.25, well, 6.25 from 10.25. So you see why it's important, let's see what's going on, right? Number one, for me, once I see a negative sign in velocity or acceleration, I am doing it out. I am listing out each one, right? So a negative sign in velocity indicates a change in direction. A negative sign in acceleration, it appears to be decelerating. So something happening to the particle, it's not just moving in a straight line, right? Something probably happening. So it's probably slowing down, probably changing direction and then slowing down. Okay, but for now, my advice here is to see what happens at each second, and then you make an estimate. Okay, well, the particle continued in the same distance. When to do it? All the time. All the time. T is 0. Once it's small values, T is 0, T is 1, T is 1. They just won't take it long. Right, else? Right, else? No, you have to do this. You have to do this. Can't get your part. Keep on out. Any questions online? Yes. They don't get to finish everything. For the shop. So you have to start. I think that's why I want to all right, let's go. Kinematics, how we this thing around kinematics. Yeah. All right, sorry. These parts, this do have kinematics in it. So let's go to 2000 and yeah, that's a good stuff. You see, once you have a small amount of time, like this stuff, right? So we should have this stuff and see what it is. Right, but we said it's not, that's zero. Now I want to keep going. A negative sign that trigger from something happening in the particle. Oh gosh. Y'all see that? Let's try this one here now. Right, so it'll minimize all, yeah. No, beside myself. Alright, let's go. Consider it toy truck moving along in Emirates and get the answer some more, yeah? Emirates and Jason and right, Sebastian, Zahara, don't forget my please. Hurry up, try this here, Eden. Eden, hurry up. Last one. Last one, you have one more. Consider it toy truck, they give you the acceleration. Assume that the speed of the toy truck is in, watch here, yeah? The speed is in centimeters per second, right? So your unit is centimeters per second. Outline how an equation for the speed of the truck will be found using the given equation of acceleration, right? 3 marks. What are you gonna do? Integrate the acceleration with respect to time. Okay? That's all you have to put in. Right? Write it down though, please. Write down the equation, right? You gotta write it down. Next part, some more to do here. So all we have to do is integrate, right? Find the speed of the truck when T is 10. Do you think? Huh? Right, find the speed of the truck when T is 10. Pardon, huh? I am not hurry up now. Right, find the speed of the truck at T is equal to 10. Find the speed of the truck at T is equal to 10. Assume it down, right? We'll come back and do we'll come back and do the whole thing that's now. Find the speed of the truck when T is 10. Did you end up with a problem when they integrate? Huh? When they integrate, problem is what? That was what the problem is. The problem is we have a C. How we getting rid of C? Emirates, well done, Emirates. Emirates send the whole thing. Very good. Yeah. But how we getting rid of C? I'm here. Anybody? When T is equal to 0. Right, so when T is 0, will the particle be moving? No. So when T is 0, V is 0. Okay? You just have to pay attention to what it's question. So if time is zero, the particle should be moving, right? So the clock should be moving. Yeah. Well, the equation is how the particle movement, how the clock movement. Like T is zero. It must be zero or something. I must be at some point in time. Information at the time. Look back. And last part before I push. Last part. Up there, right? Find the distance covered by the truck between 5 and 10 seconds. Express your answer to the nearest source. So, Olia, once you see this between 5 and 10, no, not integrate between limits. So once they give you between two values, that is where you use limits. Okay? Yeah, you work it out, you work out 10, you work out 5 and minus. That's the last part, right? Distance covered between 5 and 10. Right? Nice job, Jason. Who we looking out for now? Samir? Well, one of the Emirates said answers. Kind of online. Guys, still sleep with it. Yeah, I think so. Oh yeah. Do the last part. Olia, please fill out the form, right? Fill out the crash course form, right? It's on the group. Fill it out, please. Well, you have your camera again? I will take a go. I'll take all that stuff. Yes, best friend. Yeah. Right, last minute, let's work it out. Oh yeah, work it out fast, integrate between the limits, right? So it'll be really easy when they give you limits because you know you're just plugging in those two values, right? Well, I think until 10 pounds, well, see the part of the type of the digit that makes sense. 5 feet. Right, so when you integrate 9t squared plus 2t minus 1, when you integrate it, you'll end up with 9t cubed on 3, which is 3t cubed plus t squared minus t plus c. Everybody okay with that? Problem is plus c. So we know that when t is 0, technically we had to assume that the particle is not moving, right? If they don't give you t is 0, b is 0. And then plug it in, and you will get c is equal to 0. That's okay? So we know what the equation is. The equation is b is equal to 3t cubed plus t squared minus t. Then plug in t is 10. How much is that? 3090 again centimeters per second. All right. And last part. Last part, they want you to get a distance covered, so you're integrating velocity with respect to time between 10 and 5. Right. All you have to remember, you can put these values in the calculator and just check your answer, right? Check your answer. Okay? Instead of using t, use x squared. Right? So between 10 and 5, after integrate 3t cubed plus t squared minus t. So between 10 and 5, that will be 3 and 4 t cubed plus t cubed and 3 minus t squared and 2. Plug in 10, plug in 5. Right, plug in t is 10 and t is 5. What's your gun? No, you just plug in 10 after you integrate 3 here. Yeah, take an S, you have to integrate 3 again. Anybody else? Yeah, just plug in t is 10 minus t is 5 and tell me what you're gonna. How much? 2944. Anybody online? You're plugging 10 and then 5. What? When is the original? 7,000 how much? 7,200 and alright, we'll work it just plug in the 10 and the 5. I'm doing that now and I'll send the answer in the group, right?